This tutorial series will show you how to make infinite procedurally generated voxel terrain in Godot using C#, along with a player character that can break and place blocks. If you're feeling impatient, the source code for the project is available on my Patreon, link in the description. In this video, we're going to set up a system for collecting blocks into a chunk, which can then be rendered. Alright, so I've started with a fresh Godot 4.2 mono project, so that's the version that supports C#. The only things I've done is I've added in this block textures folder, where I've put a few textures in that I'm going to use for my blocks. I've also gone into project settings, naming, and in here I've changed the scene name casing to Pascal case. That's because in C# that's the convention for class names, and I want those class names to match the scenes that they're on. So that's the only reason for that. With that out of the way, we can start by creating our first scene. We're going to pick other node because we're going to want this to be a static body 3D. So this is a 3D physics body, and this is going to represent our chunk. So if you're familiar with how something like Minecraft works, instead of making every single individual block, it sort of batches them together in chunks of blocks. So when it's loading new terrain, it loads an entire chunk instead of, loading every single individual block. And we're going to use this to batch together our visuals for the blocks as well as the collision for the blocks. So to implement collisions, we're going to add a collision shape 2D to our chunk, and you can see we have a warning on this. We're going to ignore this for now. Basically, it's complaining that we haven't set a shape over here, but we're going to do that in our script as we load the terrain. Similarly, we're going to add a mesh instance 3D, and we're also going to leave its mesh empty because that's something that we're also going to set in code. So you can go ahead and save this scene. I'm going to save it as chunk. And now we're going to add a script to our chunk. By default, the language is going to say GD script. Just make sure you change that to C#. So now we create our script, open that up. And so the first thing we're going to do is we're going to add the tool attribute to the top here. What this does is it makes everything in this script run while we're in the editor. So we don't have to open up and start our project and play our game to see our changes. It'll just happen in the editor. Which will be very useful for testing. Next, we're going to define a few exports in here. This allows us to set values in the editor. And we're just going to get some references to our collision shape 3D that we just made, and also to our mesh instance 3D. Now we're going to define a few useful sort of constants that we're going to use for all our chunks. These are going to be static instead of actually using the constant keyword. That's just because since it's a vector 3i struct, you can't use constant. So don't worry about that. We're going to call this dimensions, and this is going to define the size of each chunk. And we're going to set that to 16 by 64 by 16. So that's 16 blocks wide, 64 blocks tall, 16 blocks deep. Next, I'm going to copy paste in some values. So this vertices array contains the position of each corner of each block, essentially. So, you can imagine a cube. There are 8 corners of a cube, and these are all of those corners. I'm just going to fix the formatting. And now the order that these are written in is going to matter, because what I'm going to copy in next, these arrays define each face of the cube. So there are 4 corners making up each face. Each face is a square. And these values correspond to the index in this vertices array of each corner that makes up that face. So for example, for the top face, we can see that it's referencing vertices number 2, 3, 7, and 6. So if we look at this array here, index starts at 0, so 0, 1, 2. So it's these 2 corners and these 2 corners. Those make up the top face. Now the order of these values is also important, just because when you're defining a face in a 3D shape, depending on if you go clockwise or counterclockwise around the square, that's going to change essentially the direction that it's facing in. So if you get them in the wrong order, the cube might be inside out. So just make sure you get all these values consistent with each other. Next up, we're going to make a surface tool. And if you mouse over the definition of surface tool, you see that it's used to construct a mesh by specifying vertex attributes individually, and it can be used to construct a mesh from a script. So that's exactly what we're going to want to do here. So that's what that's for. Now we want to define an array of all the blocks in our chunk. You can see that the block type, of course, doesn't exist. We haven't defined it yet. And these 2 commas here just show that it is a 3-dimensional array. So let's just finish up defining this first. So essentially we're saying we want, an array of every single block that is in this chunk. So that's why we're doing dimensions.x, y, and z. So now let's close out of our code editor for now. We'll go here back into Godot. We can save our chunk scene while we're here. Go down here to the File Explorer window thing and do new script. So we're going to write a C# script. For inherits, we want it to inherit from resource. So this is the base class for serializable objects. This is going to make it so we can have an object that will be editable in the inspector over here on the right side. And this is going to represent our block. So we can create that. If we head back over to our code editor, see that we now have our block class. We're also going to want to add the tool attribute to this one as well. And we're also going to add the global class attribute. Now what this does is essentially, you can see, exposes the target class to the Godot engine. This is going to make it so we can actually use it in the inspector. Now for now, there's not really much that we want to do with this. So I'm going to do the bare minimum, write a parameterless constructor. So it's just an empty constructor. Because otherwise, when you use the global class attribute and Godot tries to use the class, it freaks out, apparently, if it does not have a constructor to use. So that's what this is for. Out of the way, we can go back to our chunk script, and we can see the blocks array is no longer complaining. Next up, we're going to want to define 2 really important methods. First one is called generate. Now this is what's going to fill up this blocks array initially with the generated terrain. After that, we want public void update, and what this is going to do is it's going to look at the blocks in this array, and it's going to generate a mesh and collision mesh for our chunk. So for both these methods, I'm going to start them out with a for loop. I'm going to copy paste this into both. And this is essentially looping through every single block position in the chunk. And then in this method, it's going to set that block. And in this method, it's going to make the mesh for that block. Just for starting off as a bit of a placeholder, we're just going to make a generic block here with no actual info for it, but that's fine. It's just going to be a placeholder. And in our for loop here, we're going to set blocks XYZ to that basic nothing block. So we're going to come back to this later and actually have this set them, to dirt or stone or air. But for now, it's just a placeholder. Now here in the update method, we are going to want to define some more methods to help out with that. The first one is going to be private void create block mesh. And it's going to take in the position of the block that it's going to create. So this way we loop through every single block, and then we can call create block mesh at that position. Now when we create a block, what we're going to do is individually create each face that makes up that block. So we're going to make another method called create face mesh. This is going to take in an integer array that we're going to call face, and this is going to correspond to one of these 6 arrays. So if we want to create the top face, we're going to pass in the top array, and it's going to use these indices to look up which vertex it's going to make for each corner. And much like the create block mesh method, it's also going to take in the position of the block that it's creating. Now we just need one last method, which is going to be called private bool check transparent, which is going to take in a block position. And the point of this is, imagine you have a block that's deep underground. It's completely surrounded by other blocks. There's no point in creating its mesh since it's completely hidden. So this method here, we're going to use it to check the surrounding blocks. And if there is a transparent block, so say like an air block, that's on top of the top face, then we would create the top face. But if there's an opaque block there, then we do not create that face. So that's what this is for. For now, we'll just have it return true. So it's just going to generate all our faces. This is going to be a little placeholder. We'll come back to it in the future. With all our blank methods set up, we can start actually implementing the update method. So the first thing we're going to do is surface tool.begin, which just, as the name would imply, tells the surface tool that we're going to start making a mesh. We're going to start giving it vertices. And it takes in a primitive type as a parameter. We're going to set that to triangles. So we're going to make up our mesh by defining every single triangle in the mesh. So you see it starts with that, then it goes into create block mesh. In this method here, we're going to start creating every single face. But we're only going to create the face if the block in that direction that it's facing towards is transparent. So for that we would say if check transparent block position plus vector3i.up. So if the block on top of us is transparent, then we do create face mesh top block position. So I'm going to copy paste this 5 more times for our 6 total faces. And then just start changing the values. So if we look at the block underneath us, we render the bottom face if that's transparent. The one to the left of us, we render the left face, and so on. So now, lastly, we're going to fill out the create face mesh method. We're going to come back to this a few times in the future to kind of fill it out, make it a bit more detailed. But for now, we're going to keep it pretty basic, where first up, we're going to get the 4 corners. So as I said before, the face array contains the indices of the vertices array that make up each corner. And then this is the position of each corner within the entire chunk, which is why we have to add on the block position to those values. Next, what we're going to do is define the vertices that make up each triangle in our square. So you can make a triangle. You can make a square with 2 triangles. So we're going to have A, B, C as our first triangle, and as our second triangle, we have A, C, D. And again, the order of these values matter. If you imagine this square, it is that A is in the top left, B is in the bottom left, C is in the bottom right, and D is in the top right. So this triangle ABC is sort of the bottom left triangle, and then ACD is sort of the top right triangle. And depending on if it's going clockwise or counterclockwise, that'll change which direction it renders in. So the order is very important. Now with those, we can do surface tool.add triangle fan, which inserts a triangle made of array data into the mesh. And we're going to give it the triangle 1 array, and we're going to duplicate that and give it the triangle 2 array. So that'll make our square out of 2 triangles. So that finishes the create face mesh method. So if we go back up to update, we can finish this out as well. So what we're going to want to do is do fair mesh surface tool dot commit. So what this does is the surface tool will then commit all the data into an array mesh. We're going to take that mesh that it just created. We're going to tell our mesh instance to use that mesh. And then for the collision shape, we're going to tell it to create a tri-mesh shape out of the mesh. So it has to calculate a collision shape to use from this mesh, and we're going to tell it to use that. And if I'm not mistaken, I think now if we go back to here and we rebuild our project, maybe close out the chunk scene and reopen it. It's not going to work. Oh, I forgot something very important. We're not calling either of these methods. So for that, we'll do public override void ready. So this is the ready method is what's called as the node is, entered into the scene. And here we're going to call generate. We're going to call update. So now we can go back into Godot and also make sure to click on your chunk and get confused because why isn't it updating? I don't know why this is happening, but Godot's kind of bugged out for me, where you can see it is not referencing the right script. So I'm just going to detach the script that it has. I'm going to save the scene. I'm going to attach the existing script. I'm going to reload my chunk script. And okay, now it's working. So hopefully that doesn't happen to you, but it did happen to me. Now that when I click the chunk node, you can see that we can now assign its collision shape and its mesh instance. So we can just drag these 2 nodes over, save. Now if we restart the scene by closing it and opening it again, now it actually works. If we zoom out, we can see we have this nice chunk of blank sort of undefined blocks.